how this is crucial for machine learning. And this is where I want to motivate you that why you should be learning learning linear algebra, and why you should master it as well. So this is something that I asked ChatGPT to generate, to give me an analogy on what is linear algebra to machine learning. So linear algebra is to machine learning what ingredients are to a chef. Okay. So linear algebra is as important as ingredients are to a chef. So a chef, if anything he or she is cooking, ingredients are very important, right? Without those basics, he can't make any dish, right? So linear algebra is similar for machine learning. If you don't have linear algebra, you will not be able to do anything in machine learning. Okay. And let's see from where, and we'll see like where all machine learning is used. I'll give you a very brief introduction. And if I have to talk about where all linear algebra is used in machine learning, I think we'll have to take multiple lectures. So we'll not do that. I'll just give you a very brief overview on how linear algebra is being used in ML. Okay. So this is a very interesting meme or a comic that I had came across when I had joined ISC. So if you go into the CSA department, there are whiteboards there. And when I had joined ISC, I saw this and I didn't really understand what it meant. Like, oh, why is this guy saying that, oh, this is your machine learning system? So this guy is saying, this is my machine learning system. And this guy is saying, yeah, this you just pour in your data in this big pile of linear algebra, and then you collect your answers from here. So this guy says that, what if the answers are wrong? So he says that, oh, just stir the pile until they start looking right. So this is actually very true. You might not get it right now, but once we complete machine learning, you will understand this. This is so true that you just keep on juggling or stirring the linear algebra in a machine learning model till your answers are looking right. Okay, so you just play around with linear algebra while you're doing machine learning. Obviously, you use probability to do very basic fundamental modeling, but to do the operation and to actually train a model, you use linear algebra. That will become clear as we go forward in the course and when we start machine learning. But just remember this and see after 3-4 months, are you able to relate to this? Okay. So first of all, why like ML? Why are we even talking about machine learning? So machine learning is currently creeping in everywhere. Okay. So up till last year, I think nobody was using ChatGPT, but now because ChatGPT is free, and I was also trying to understand vector and how to explain a vector to a 5-year-old. So this is what I asked ChatGPT, and now everyone is using ChatGPT these days, right? So I'm pretty sure you must have already used it, and if not, try to use this. And it's pretty cool, right? And recently, I received some students reached out to me. Can you please review my essay for my MTech program? And I could see that they had taken it from ChatGPT because it's very obvious when the content is not written itself. So all I'm trying to do is everywhere this ChatGPT is creeping in and everybody's using it. And so this is also a machine learning model, right? So ML is basically going way beyond what we could have imagined 5 years earlier. And it's very accessible also. Now, also, if you have seen voice assistants like this Alexa Echo Dot, you will see that ML is also used here. So how does Alexa know that what am I saying? And how does Alexa process whatever the audio data is, right? So there is no human sitting at the back of this Alexa, right? It's a machine learning algorithm, and a machine automatically cannot process this, right? So there is some way that whatever data we are talking or whatever audio I'm giving out, it's being processed by a machine, right? So all I want to say is that you can see machine learning is creeping in everywhere. You can see it in voice assistants. You can see it in ChatGPT. And this is something that I recently used, that in Google Photos, I was actually looking for some food that I had eaten some years back. And I just searched for food, right? I manually did not tag this data, and it got automatically tagged in the background of Google Photos. Similarly, I was looking for some memes that I used to screenshot some years back. So I can just type in meme, and Google has already run some algorithm to categorize these images that we have into different categories. So here again, ML is being used, right? So where does this linear algebra come in ML? So where is the starting point of linear algebra in ML? So first of all, understand that there we now have abundance of data. Okay. So when digitalization was not happening, maybe we did not have digitalized data, but now once computers came in, internet came in, everything that is on screen on your computer is data, right? So suppose that I took an image or I took a picture on my phone. This is a picture I took. This is data, right? The video that we are recording right now, right? The YouTube videos or whatever we are recording right now, YouTube videos or lecture videos that we are recording right now, this is also a data, right? Whatever I am speaking, right? So some signal is going in. So this audio is also a data. So we have a lot of data, and I want to use this data to do something. And that something is basically machine learning. And I want to use this data, for example, to teach my machine how to generate subtitles for the things that I have spoken. So I want to generate subtitles for the things that I have spoken, and I want to automate that task. So how will I start? So how will I start is I will start with representation of the data. Okay. So let's see some examples on how we can represent data. So I was working in inference, and it was a biomedical startup that was using AI to generate insights from the biomedical data. I majorly worked on this project where we used to train machine learning algorithms to detect diseases given an ECG. Okay. So first of all, the first problem is how to represent the data. How do you do the representation of the data? So this is the signal. ECG is basically electrocardiogram, and this is a very cheap test that you can get it done. And there is a way we used to represent this data. So we used to take so this used to be like a matrix. So this is where, the linear algebra is coming in. So this matrix used to be something like 1 cross 5,000, 12 cross 5,000 actually. It's 12 cross 5,000 because, so this is one lead. There used to be other leads as well. Okay, so every lead corresponded to 5,000 data points. So we used to have like vectors of 5,000. And we used to have 12 such vectors. And that data used to go to our machine learning model. Right? So here you can see that matrix is being used to represent the data. And this is where linear algebra is coming in. Again, we used to have these slides. These are tissue slides. So basically, whenever you get the biopsy done, and you might have seen this, we do this onion experiment when we are in 10th class, that we peel off the skin of onion and we try to visualize it under the microscope. And you might remember that it looks like this, right? So this image, when this gets digitalized, you can represent this image as a matrix again, right? And a very usual way to represent this is pixel values. Pixel values, so for example, 0, so pixel values go from 0 to 55, and you can fill in these values here and there, and you can choose a size that you want to represent it in. So again, we are using matrix to represent the data that we have, right? So whenever you are training an image classifier. For example, I want to differentiate between a cat and a dog. So cat image is also represented as a matrix and given to the ML model. And dog image is also represented as a matrix and given to an ML model. Then YouTube video, right? So this YouTube video, so there are multiple modalities in this. Multiple modalities as it. So this video is actually nothing but frames of images, right? So every second there'll be like a image, or every millisecond or something, there'll be like an image, or the video that we are recording right now. Every time step there'll be some image. So every image will be represented using a matrix, right? This is also a matrix. And this is also a matrix. Matrix. Right? And these are basically collections of matrix that we have. So this is just the image data, like what you can visualize. But what you can hear is the audio, right? So audio is a signal, right? It's a 1D, 2D signal. So it is something like this. And you can represent it basically using a vector, right? So maybe I will represent the audio using vector. So you're using matrix and vector. Vector is also a special type of matrix. You're using these matrix and vectors to represent the data that you are sending to your machine learning model, right? Then also, once we have, input the data into our machine learning model, we can also do other tasks. For example, we can learn some meaningful representation of the data. When I say meaningful representation of the data, so answer this question. How does ChatGPT knows what I'm asking, right? I'm saying, explain me what is a vector in linear algebra, like I'm a 5-year-old. And you can see the response is pretty cool, that it's actually explaining me linear algebra or the vector in a form of, like I have to go to a swing, like I'm a 5-year-old, so I only know about swings and I always want to go to a swing. So it's coming to this very good answer, but how? How does a machine which understands only binary knows what I'm asking, right? So somehow, when I trained my model, whatever text I was giving to this model, so this ChatGPT model is there, ChatGPT model, right? And I have to send this question to this ChatGPT model, right? So somehow, whenever I send this data to this ChatGPT model, it was able to understand what this English sentence meant. Though machines can only learn or understand, machines only understand binary. Understand binary, or models only understand numbers, right? Models understand, because you're representing this data in form of numbers, so it'll only understand numbers, right? So how is that it knows that I'm a 5-year-old, so it has to tone down, it has to bring in context of swings, playground, so that I'm able to understand better, right? So for this, I'm digressing a bit. This is not part of the course as well, but this is how it is done. I don't know if this is coming up, but okay. So suppose I am saying I have a cat. Yeah. Okay. So one way I can do is I can allocate, I want to represent it in some format and I want to give it to my machine learning model. So one way I can do it is method one. I can do it is for every word that I have in my dictionary, I'll allocate it some number. For example, 0, 1, 2, 3, right? I have a cat, right? But this particular number doesn't actually capture the semantics or the context around these words, right? For example, if I have to talk about apple, which is like this apple, and actually I have it front here. So if understand the difference between this apple and this apple, how does my machine will understand that there's a difference? So it has to basically learn some context, right? And that's also where linear algebra is used in learning these meaningful representations. So for example, this is a very quick up example, but what I'll do is I'll learn a vector corresponding to this. Learn vector. How we do it is not part of this lecture, but somehow say I learn a vector corresponding to this apple. And I also learn a vector corresponding to this apple. Okay. And I plot it in my 2D plane. Okay. So for example, I have this red apple over here. And this black or white apple over here. This apple over here. This is the icon, right? So suppose I subtract a representation of, say, fruit from this apple. I say I want to do fruit. I want to do fruit, subtract fruit and add a representation of company, which might have learned through some process that I have done. Then it should give me this. Okay. So I want this red apple minus the fruit, the representation of the fruit, plus the representation of a company should give me this apple. Okay. So to do all this, I will actually use linear algebra. Fine. And there is a very popular example from this representation learning that we do using machine learning, using linear algebra in machine learning, where they actually plot these vectors, whatever representation they have learned for king, man, women, and they can see that actually when they, so this is my king vector. This is my man vector. This is, for example, my man vector. And this difference, if they suppose they do this difference, like they remove this thing and then they add the queen vector, the women vector, for example, women is here, right? When they add this vector, they actually get the representation of queen. So the difference between, the vector, like the difference between the vector representation for king, man, and when you add women vector to it, you actually get the queen vector. Or suppose instead of this, you have uncle minus man plus women. You actually get an ant vector, right? So in learning these useful representations and also visualizing them, we use linear algebra. So this is something that we'll be learning in the course itself. This is neural network. So these are my, so my input here will be like a vector. So this will be my vector, which is like an input vector. And when this data, these are my neurons, and these are my hidden layer neurons. And this basically is nothing but a matrix. Right? So when you actually move forward in the neural network, all you are doing is a matrix multiplication with a vector. So again, linear algebra is heavily used in neural networks. And there are many more things where, many more places where linear algebra is used. We talked about natural language processing when we talked about ChatGPT. Then in vision domain, when we talked about, audio or the images, how linear algebra is used to represent the images. Then also robotics. If you have seen any robotics platform or any video of robotics, machine learning is heavily used to visualize the plane that the robot is walking on and what direction to go in is all vectors and matrices. There are some things that we will see SVD and PCA in this course. So these are purely linear algebra concepts, right? And literally everywhere in machine learning, we have linear algebra, right? So coming back to this comic again. So I don't know if you are able to appreciate this still, or it might take some time because it took me some years to understand what it really meant. But it essentially what I want to conclude this lecture with is to do machine learning, you have to be very good at linear algebra. And that's the reason why GATE course has so much focus on linear algebra. And also probabilities are also an essential part of this. So build your foundation very strong. If you want to continue doing machine learning, you want to learn machine learning, build your foundation very strong with linear algebra. That's all I wanted to cover for today. And this is like an introduction lecture. I just wanted you to motivate on why you should be learning linear algebra and why you should be mastering it as well.